Radians! In order to do this one, sorry, I'm sorry, I scared you. What are some common radian angles that you guys are used to?
Pi over 3.
Okay, let's go. We got pi over 6, and then pi over 4, and pi over 3, right? We pi over 2 is even worthy of noting, but we probably won't use him very much. Now, how do we split apart a pi over 12 with angles that we know? Because that's our goal. We want to split this up with angles that we know so that we can use the sum or difference formula. The problem with fractions is when the denominators are not common, it's hard. So let's find common denominators. Let's make all these with the denominator of 12. Shall we? We shall. Okay, now some of you guys might start doing a lot of stuff in your head, but since it's the first time, I'm going to write everything out. So if my denominator is 12 for pi over 6, what's the numerator going to be? 2 pi. And then this one's going to be 3 pi. How do we get that? Because you have to multiply a bottom by 3 and a top by 3 if you guys want to have a denominator of 12. And then this next one would be 4 pi. That doesn't look like a 4. It kind of looks like a 9. Okay, 4 pi. And what about the last one? 6 pi. Okay, so now it becomes a lot more simple to split up this pi over 12. How can I get 1 pi over 12 with any of these? Can you guys tell me? What do you guys want to use? You can pick. There's actually two different ways of doing it. Did anybody say 3 pi over 12 minus 2 pi over 12? No. Would this equal?
Yeah.
1 pi over 12?
Yeah.
Okay, so maybe you guys can see where I'm going now. Because I have subtraction inside here, I can use a sum or difference formula. So this equals sine 3 pi over 12. Wait, what is 3 pi over 12? Let's rewrite that. What is 3 pi over 12? This is sine of pi over 4 minus pi over 6. So we got sine of pi over 4, and then cosine of, let's put parentheses around that guy, times cosine of pi over 6. And then is it minus or plus? Does it switch or does it stay the same? Stay the same. So then we have cosine of pi over 4 and then sine of pi over 6. And we can do those. I can put parentheses around these. These don't matter.
How do you know if it's minus or?
Yeah.
Based on what the original expression says. You see how this says minus?
Yeah.
So for sine, the formula has a minus. Now, guys, I'll give you the conceptual lesson behind that formula on Monday. Today, I just want to teach you procedures, like how do you use it. So this is how you use it. I split it up, and now I write out the formula, and now I find them. Now, what is sine of pi over 4? That's rad 2 over 2. What is cosine of pi over 6? Rad 3 over 2. Minus. Now we have cosine of pi over 4. That is also rad 2 over 2. And then sine of pi over 6. That will be 1/2. We have to multiply. So let's get rad 6 over 4. Minus rad 2 over 4. Hey. Already have common denominators, so let's just write that out. Rad 6 minus rad 2 over 4. And that's our answer. This is an exact answer. There was no rounding done. This answer is exact. Now, if we take this answer and plug it into a calculator, and then also plug in sine of pi over 4 into a or pi over 12 into a calculator, we should get the same thing. Okay, let's see what we get. So let's see if we get the same thing here and the same thing right here. Okay, so after I plug that in, I get, boom, 0.2588. So you guys got too? Okay, and then I'm going to use radians, so I need to make sure I'm in radians. I hit mode. Oh, no, I'm in degrees, so I got to change this to radians. So I hit quit. Now I'm in radians. What was it? Sine of pi divided. Okay, so pi is right here. Pi divided by 12. Same thing. So we get the same thing, but this right here would be your more exact answer. All right, so that's how you use sum and difference formula with sine.